Or we know? Or we know? Now, I want us first to quickly recap what we learned in the previous sessions so that we can continue from where we stopped last time. Luckily, that object-oriented programming is a programming paradigm which were created so as to solve complex tasks that other types of programming languages, that is procedural or structured programming language, were unable to handle. In this case, they introduce classes and objects so as to make some codes, some similar codes which are procedurally structured by them to be an object, to have an object figures. And in that context, some programmers like Strogram come up with object-oriented features. That means they have paradigms that make codes simpler and easier to understand. In previous lessons, we understood that C++ is one of the object-oriented programming language, and we say that C++ is an extension of C, where now we have to create some objects to solve complex tasks. Okay? Again, we agree that a class is an instance of is a blueprint of a block of objects. An object is an instance of a class, right? And again, we agree that the structure of a class must begin with an uppercase. For example, we had a class students. We say that students class should begin with an uppercase S. We agree that. Okay? And we say again a class should be created outside our main function. So that for the other classes to access that class, right? Rather than when we create a class inside the main function, that means other classes will not access the attributes of that class. Was that clear? And then we say that when creating an object, we must begin with the class name, then the object name now, so that to be executed in our main function. Okay? And again, we agree that in C++ we have four main pillars. We have encapsulation, we have inheritance, the other two, abstraction, yeah. I've said encapsulation, another one, inheritance, okay? We have said inheritance. Yes, polymorphism, okay? And we also handled, I took you through the case of encapsulation, that is data hiding. It's a paradigm for hiding data, so as other classes cannot access it directly, right? I'm not saying it should not be accessible, but I've said should not be accessed directly or modified or change of data, right? Now, in this session, we're going to discuss on constructors, right? Constructors, and by the end of this session, you as learners, you should understand what's a constructor. You should understand how constructors are used and apply the constructors in real world, right? Right? Yes. Now, when I was noticing classes and objects in object-oriented programming language, we created a class called, do you remember? We created a class called students, right? And then we declared some variables for that student inside our class, okay? And then after there, we created an object of that class, right? And then we displayed the names of the students, age, and what was the other one? It was name and age, Yes. Now, assuming that we have hundreds of students in this school, we have tens of students in this school, or even thousands of students, and we want to display their names. When we are executing these programs in the main function without a constructor, that means we have to initialize each student with their names, their ages. Is that clear? So let me display one with what we did last time. Alright. We had a class student. We had student 1, right? We had student 2 and student 3, 4, maybe 5, 6, 7, 8, 9, and 10, or even 20 students, right? We are supposed to display this data for these students on our console or our terminal. Let's run this program, you see. We say that Francis is 23 years old, Alex is 30 years old, and so on. Titus is 21 years old. We agree that, right? Now, if you see this program in our independent function, you see that it's a lot of codes. There's a lot of repetitions. Each student is initialized with his or her values. The other student. So if you see this, it's very tiresome. So clear? Now, I don't want us to just code for every student, every time. Very tiresome, right? Now, I introduce you with a concept called constructor in C++ or in object-oriented programming language to solve this problem. You see here, it's a lot of repetition, right? Okay? Now, a concept of constructor at this level of knowledge is where now, first of all, a constructor is a special method. Last time we agreed that method in C++ is a function inside a class, right? If you see this program, here we have two methods. The one method to display age, right? To display age. So what's a method in C++? It's a function. It's a function inside a class. It's a function inside this class, right? Now, a constructor now is a special method. It's just like this method, but we call it a special method in a class. And it's created inside a class, just like this method here. But a constructor is a special method that initializes objects of a class. Alright? Let me define so that you understand. Constructor it is a special underline special methods. Alright? Method of a class that initializes the objects. So that means this method called constructor will be invoked or called when we create an object. So we shall see that one when we do some when we set some instructions here, so as to solve the problem of repetition. We have said that a method is a special, a constructor is a special method of a class that initializes the object, and it's called or invoked when so I've said it's called or invoked when an object is created. We shall see that one in advance. Now, write this one so that I can do something else. Not down. So I want us to write the same program as this one, but now with a constructor so that we can compare. And indeed we shall agree that with constructors everything is perfect, simple, and easy to learn. Now, let us quickly write a C++ program. After that, we write a class. Very nice. So a class begins with as a class keyword, and then our class name is student. Right? And then open a curly bracket. Let me ask you a question. Why are we putting it public? Raise your hand. In the previous sessions, we agreed that we have three access modifiers: public, private, and protected. Alright? So public, the public access modifier allows other classes outside this class to access this data. And our data here is we have name, right? Then we have our variable here, age of type integer. And then properties of a student or attributes of this student. Now, what are these or are behaviors? We want to display the age of the student. So it should be public. Void display age. Okay. And then if I say display age, that means display it on a screen, right? Or at the terminal or the console. So we see out with an insertion operator. Name, then is H, and then N. Now, these are methods in C++. These are methods, it's a function inside, right? And the purpose of this function here is to display the H to the screen, okay? Now, I want us now to come up with the concept of constructors. We have agreed that constructors in C++ is a special method. It's just like this method, but it's a special method. When we say special, it means it's an advanced method inside a class. Right? Writing a constructor has 3 rules. Okay? To write a constructor, it has three rules. Rule number 1, it should be public, right? It should be public. Rule number 2, the name of the constructor is exactly like the name of our class, right? What was the name of our class here? Raise your hand. Name of our class? Yes. Student. Very good, right? Now, when we are creating a constructor, that name student should be also the name of the constructor, okay? And then rule number 3, constructor has no return type, right? When I say return type, if you see other methods like this method display age, it has a return type, right? Which return type is void. And we say void return type here tells the compiler that this method will not return anything, right? But constructor has no return type, or even this point, it has no return type. So I've said 3 rules of writing a constructor. 1, yes, declared in a public section. Another, yes.
The name should be the same as of the class.
Very good, Francis. When we are learning constructor, same as the name of the class, right? Another rule. Yes. It has no return type. That means, unlike the other methods inside our class, which has a return type, for its return type, that tells the compiler it doesn't return any value, right? Now, let us start constructor so that I can explain. Outside should be public, so this continuity, right? So assume this public, this section is still public. So it should be the name should be named same as the class. Then remember it's a method. A method should have parentheses which carries some parameters so that we can uh, so that we can pass some arguments later. Now, okay, let me just write it in this. By default, the compiler understands these are default compilers. These are default constructors. Why? Because we have not passed some parameters. If we pass a parameter, it could we call it parameterized constructor, right? Now, but for our case, we don't need a default constructor. We need a parameterized constructor, right? Now, when I say a parameter, it means we must pass some parameters so that we can initialize later when we are creating the object, right? Now, I want us to make some parameters here. The parameters that we shall make should be should be related to what we declared on our class, right? So student name, it's just like declaration. Student name, and then student age, right? Here, inside these curly brackets, we want to tell the compiler that the variables we declared inside this constructor is just the same as the variables we declared inside our class, right? Now, name is assigned to student name, and age is assigned to student age. Alright? Like that. Let me explain in detail. We have said here, this method called the constructor is just like this method here inside our class, but a constructor is a special because